Okay, in this question, what you're given is a bunch of medicines to look at, and L-Dopa, dopamine, and ibuprofen, and they've given you the structure of these, and they're asking you some questions about these structures. Your ability to analyze an organic compound is being tested here. All right. So name the functional group that is present in both L-Dopa and ibuprofen, but is not present in dopamine. Okay, so let's find some functional groups. Well, if we look at L-Dopa, we've got hydroxyl group here, a hydroxyl group here, and a carboxyl group here. We also have an amine group here, but you haven't learned about these in National 5 chemistry, so you can safely ignore that one. If we look at dopamine, it's got hydroxyl, and amine. NH2, you can say it's a group, all right. And finally, in ibuprofen, we have no hydroxyl group, we have no amine group, but we do have a carboxyl group. And what were we asked about? We were asked about ibuprofen and L-Dopa. So the answer is the carboxyl group, this one here, COOH and COOH. Now, a couple of things you need to notice about this question. It says name the functional group. It doesn't say draw it, and it doesn't say write out its formula. It says name it, and the name is carboxyl. You could put group in, you don't need to, just carboxyl is enough. If you put this in, COOH, it's wrong. You'll get marked wrong for that. If you put in carboxylic, that's wrong as well, because it's not the name of the group. Carboxyl is the name of the group, okay? Key step in producing L-Dopa involves addition reaction with hydrogen molecules. This is carried out using a catalyst. Name the type of addition reaction that involves the addition of hydrogen. Okay, so again, you can ignore all this up here because it's got nothing to do with the question. The question is just asking you what's the type of addition reaction that involves the addition of hydrogen. And the answer to that is hydrogenation. The thing to do here is to make sure you don't mix it up with hydration. Hydration is the addition of water. Hydrogenation, try and say that 10 times fast. Hydrogenation is the addition of hydrogen. Okay, so the trap there is to mix it up with hydration. So you just got to be clear in your knowledge of your vocabulary. Vocabulary is so important. All right. State what is meant by the term catalyst. Again, here's another vocabulary question. You got to know what a catalyst is. You've learned it's one of the 4 things that speeds up a chemical reaction. So it's a substance that speeds up a chemical reaction. Now you can put in here without being consumed by the reaction or is recoverable at the end of the reaction, some of that stuff, but you don't need to. All right. So here we go. Many medicine molecules contain a chiral carbon, which can affect their ability to work as a medicine. Now everybody's going to go, hang on a second, my teacher didn't tell me about this chiral carbon nonsense. What's going on? Well, the point is that you sometimes get thrown something. So you're asking yourself, what is a chiral carbon? They will tell you if it hasn't been taught to you by your teacher. They will tell you, and here it is straight afterwards. A chiral carbon is any carbon atom that is attached to 4 different atoms or groups of atoms. Okay? So the chiral carbon in the L-Dopa molecule is circled. There it is. So let's have a look. Chiral carbon is any carbon atom. There's a carbon atom, right? That is attached to 4 different atoms or groups of atoms. Okay, so it's attached to 2 carbons either side, but one of these is our carboxyl group, and the other one is just another carbon in the chain, which itself is attached to more stuff. At the other end, it's attached to a hydrogen, and at the other end, it's attached to a nitrogen. So that counts. Okay, so being attached to a hydrogen counts. Being attached to a carboxyl group counts, an amine group counts, and just part of the rest of the chain counts. Okay, so let's see. Ibuprofen also has a chiral carbon in its molecule. Circle the chiral carbon in the ibuprofen structure above, okay? And here it is here. Again, we'll just follow the same rules that we had above, right? So being attached to a hydrogen is okay. Being attached to, this is a methyl group here. Being attached to that is okay. Being attached to a carboxyl group is a separate group. And being attached to this hexagonal structure here is also a separate group. So that's it. If we go down here, we see that these carbons are both attached to hydrogens. That's attached to a hydrogen and 2 carbons that are just part of the chain. So those don't count. There's your correct answer there. All right. And it says here an antagonist is a medicine that works by blocking the body's normal function. And painkillers are common examples of antagonists which work by blocking the body's response to pain. Name the medicine from the table on page 12 which would be described as an antagonist. Well, what are we looking for? We're looking for a painkiller, right? You've just got to work out the literacy of this question. It's an antagonist. An antagonist is a painkiller, is an example of an antagonist, right? A painkiller is an example of an antagonist. That's all you need to really focus on here. and that's find a medicine. So what we're looking for over here is a painkiller. And luckily, they've told us what the medicines are used for. So treatment of Parkinson's disease? Nope. Treatment of low blood pressure? Nope. Treatment of pain? Woohoo! And inflammation. So ibuprofen is our answer. You're going to write that in there. Okay?